How's it going?
Good.
Good. Are you glad it's Friday?
Yes.
Me too. All right. So first, I'm going to ask: is there anything that you've been working on that you have questions about? Revit. Specific. We'll stick with Revit for today. Revit question.
Well, what I said earlier when we were at that meeting, we're try to find those windows.
Okay.
And also how to change the way you view something on a floor plan when you, because I've tried to use the underlay, but sometimes it doesn't work. It keeps saying unbound.
Okay.
And I don't quite understand that.
All right. So, a couple things. Let's go to. Let's see here. And look at that. You made a 3-car floor plan. So there's a window right here. We'll start with this one. So there's a tool within Revit that is this guy right here under View. And it's kind of in a weird place. It's under Plan View and then Plan Region.
Okay.
Okay. I have PR set up as a keyboard shortcut. But essentially what this does is it lets you draw an area and then change the view range. So you're familiar with how the cut plane works, cut plane, top, bottom, and all that stuff. Okay. So for instance, if the cut plane for for the main view is at 4 feet. Okay. And this window is at, I was going to open up here so I can do some sketching because I like sketching. Let's find something that's a little bit thicker. Okay. So helps if you can draw straight lines, which apparently I can't. All right, so let's say you've got just a house, just a normal section like this. Okay. Typically when we this is just a quick overview. When we draw a floor plan, that floor plan is basically a section, a horizontal section, at about 4 feet. Okay, so anything that it cuts, if there's walls here, you know, typically a window is somewhere in this range, right? So anything that it cuts is seen in a floor plan. And then sometimes we have, like in the window that's in question, like this, we have windows that are above that cut plane. So we need a way to see those objects. And you can use this for, like if you want to show a split level, if you have one floor plan and you want to show a split level, some objects that are above the cut plane because the stairs go up to it or something like that, you can use this also. But what you can do is, so let's say that this window, the bottom of that window is at 5 feet tall. So you would need it to be, the cut plane to be somewhere between 5 foot and 7 foot, depending on what the height of the window is. So if we just change this to, we're just going to say 6 feet for now. And we hit finish. So we can now see that window. And the only reason we can see it is because of this plane region.
Okay.
Some things to be aware of is that if you have this plane region kind of sitting in the middle of some objects, sometimes it doesn't really know what to do with that. So like you see, if I drag this down, it looked like it changed that right there. See how that joint is a little bit different? Mm-hmm. So you kind of have to be aware of where your plane region intersects different objects. So like if I move this down here, that's going to be a little bit different too. So if things look weird around a plane region, a lot of people like to hide those plane regions. They don't print, so there's no reason to hide them.
Okay.
I'm not a big fan of hiding things that don't print in a plan, because then it's just another step that someone else has to do in order to modify it.
Yeah.
You know what I mean? And sometimes it can look a little bit messy, like if you're on these elevation views, you know, and all these boxes have actually been turned off. Actually, it looks like the view's not even cropped. It is cropped. It's like, even to the point sometimes I don't even turn these boxes off because they don't print. And I don't turn them off because even though it's one extra step, it's an extra step that someone has to take in order to change the crop of these.
Yeah.
These projects, it's not as big of a deal because they're mostly already at a completed phase, so we don't have to worry about that. But you don't have to hide this. It doesn't print. They're easy to modify. You can just drag them in and out like this. And then the view, they only have one property, which is this right here. Typically, all you're going to change is the cut plane and the top plane. If the cut plane is above the top plane, then you'll change that.
Okay.
And then the view depth in the bottom, you'll want to usually be the same as your base floor plan,
okay,
which is this property right here, view range. Dialog box looks exactly the same. Okay. And there's actually, if you ever want to read more about the different zones and what they do, you can click that. This is actually pretty good, one of the better explanations of how things work in Revit. So it's pretty good.
Okay.
Pretty good information if you want to take a look at that. Okay. All right, so then there's that, and then you also want to talk about how to use underlays a little bit better. Okay. And here. So underlays are they're a little bit weird. Because they're reliant on how the view is set up and also how other views are set up. So if I want to do an underlay of this, all right, let's say underlay, we're going to do one from dormer plate, right? And that's going to show us, or it didn't show us the roofs. That's because, are you using this in a, I don't think you're using this in a, are you using this, well, it doesn't matter, I'm not saving it, so I'm going to take the view template off so that we can turn the roofs back on. Okay, so now we can see the roof as an underlay on this. Okay, can you see it?
I get, that's what I was actually trying to find, but I couldn't. So
it might be, sometimes it might be that the underlay is not showing something because in the visibility graphics something's turned off. So the underlay is also affected by visibility graphics. So if that roof isn't showing up, it might be because it's actually turned off.
Well, well, maybe I didn't check that. I thought I did.
Go back and check again.
Okay.
If it's not, then it could always be that wherever your underlay is set is not quite reaching, it's not able to see what's going on. So the underlay, basically what the underlay is doing is it's projecting the view of this level, all right, as an underlay, which usually means halftone, onto this view. You can select the objects usually. So I have a roof there somewhere, I think. Maybe not. There it is. You can tab through. You can select the objects that are in underlay. There's an option down here to where you can turn that off so that you cannot select objects that are in underlay.
Okay.
So if you don't want to accidentally do something, you can turn that on and off. But so the first thing here, this is the base level of the underlay. Okay. So the issue with this is there's no way to control the cut plane of that, and it's usually set at whatever the view is set at. So if your first floor plan is cut plane is set at 4 feet, then if you do an underlay of the first floor plan on any other view, it's going to be set at 4 feet. It doesn't matter what your cut plane of the second floor or third floor is. Okay. And if you change the cut plane of first floor, it's going to change the underlays too. Okay. Which is weird. I haven't been able to figure out consistently how to control that, but I do know I have been in the past able to control what that underlay looks like. Okay. It's a little weird. Okay. Top level is basically in your dialog box. It's the top range that your underlay shows objects that you can select. And the best way for me to describe that is to go back and explain a little bit more about view range. So you see how I can't see that window, but I can select it. Mm-hmm. Okay. The reason that is because my top for this is at a height that includes that window. So if I change this to 4'6", I can't select that window because my top range doesn't include that object. Okay. Okay. So what you're doing essentially, and you see now I can select it, even though I can't see it. So what you're doing with underlay when you select a top level is you're giving it a range that you're able to not see things but select things. Okay, that's if the orientation is down. Okay. If your orientation is up, then the top level is the height that you can see things. Okay.
I understand it. So that means visualizing it if you look up.
Yeah, exactly. So if I want to see the ceilings in this case, okay, for some reason, telling it 8-foot plate, some of the ceilings actually showed up, even though they're higher than 8-foot plate. So sometimes, usually, this has to be either unbounded, which means you're just looking at an infinite distance. Okay. Okay, in order to see those objects. So if let's see if this works. So if I do 8-foot plate, okay, we saw some objects disappeared. We can see our fascia. We can see a roof here, probably because it cuts right here. We can see the ceiling, but we can't see the roof beyond this. And the reason for that is because the ceiling is hiding it. So if I hide that ceiling, I can now select that roof. Okay, it works just like normal objects. And depending, I don't know if your settings are set up to where when you select something, it goes transparent, see through it. Does yours do that? No?
Are you talking about a mind weight? Or
Nope.
just-
So if I select this wall, it's going to go transparent so that I can
yes,
see
it
objects
does.
behind it. Okay. You can turn that off if that's annoying to you, but sometimes it's a good feature to have. So like here, what are we at? We're at 8-foot plate and we're looking up. Okay, so I can see the ceiling. All right, I can select it right there. And if I hide that, I can see the roof beyond it. And I think the reason we can see this roof is because it's actually sitting at the 8-foot plate.
Okay.
So an underlay doesn't cut at the top plane. What it does is if so this, coming back to my sketch here, when we're looking at so let's say our 8-foot plate is right here, okay, and our underlay, I'll do curvy pointers instead of pointy pointers. Okay, if our underlay includes, so our base for the underlay, in this case, is the floor plan. Okay, so this is actually our base for our underlay is right there at that cut plane. Okay, and what we're actually telling it is that we want to look at everything in this range from here up. That's our underlay. Okay, now because our roof is actually sitting at 8-foot plate, it's actually going to include the entire roof at the underlay. It's not going to cut it at the 8-foot plate. Okay, so you kind of have to be aware of the objects that are in that zone. So we can see the objects in this zone include the beams, which are across here, and it could be that it's just barely in that plane, right? Yep.
Is there a way that you can select a model line and place it on a certain view range?
Yes, and I'll come back to that in a second.
Okay.
So model lines on work plane. All right. So you'll see that some of the stuff, even though we're able to see this point on the roof, there's actually some stuff that's up here at like the 9-foot level that we're not able to see, like the patio roof here. Okay, and if I change this to 9-foot plate, we'll all of a sudden be able to see that stuff because we basically increased the range to there.
Yeah.
Okay, so even though we were able to see things beyond that, the object isn't based on that within that level. So it's all about the work planes. Okay, so the work plane of this ceiling is 8-foot plate. All right, but the work plane of this is 9-foot plate. So we're not going to be able to see that unless our range for our underlay is using 9-foot. Okay. And then unbounded is you're just seeing everything. Okay, just from here and up. Okay, just everything up in there. Okay, does that make sense?
Yeah.
Now, given all that, sometimes it just doesn't work. Sometimes, no matter what you set this on, for some reason, things don't show up. They're turned on visibility graphics. They're within the range that you're wanting to look at, but for some reason they don't show up. And that's the point where you kind of have to get a feel for, is it worth it spending time to get it done right, or should I just draw the line?
Yeah.
Literally draw the line. Where do you draw the line for drawing the line? And you know, we're not, especially for Patriot Homes and for our residential projects, it's not really critical to get the model really hyper accurate. When we do commercial projects, it's going to be a little bit more important because those models can become coordination tools, and we need to have things that are above our view plane modeled accurately so that we can coordinate, especially with ductwork and plumbing and things like that. So So keep in mind, residential, just get it done. But commercial, we want to spend a little bit more time getting it modeled accurately to make sure that we have coordination items. All right. So if you want to put a line on this view, okay. So let's say you want to put a model line well, you tell me give me a scenario what you're trying to do.
For instance, the model line in the kitchen, it was
for those beams.
Yeah. Well, for the slope.
Okay.
And the model line was there, but it was underneath the cabinet. Yeah. I mean, not cabinet, but the countertop.
So, a couple things. I really want you to try to start using detail lines for things like that if you're going to do that. I know it makes it easier because it shows up in all the views, but the other problem is that it shows up in all the views. Uh-huh. So it's I have a hard time explaining why I do detail lines instead of model lines, because I understand the benefit of using model lines, but for some reason in the course of me working in Revit, I've just decided that I don't like having to deal with that line in every view that I go into. Mm-hmm. So I'll say that, but I'm going to let you come up with however you prefer working. Okay. Okay. So, and the other issue is what you end up doing when you're trying to do what you're doing is, let's say you want to. We don't have model lines right here yet, do we? Or we don't have. Do you have any lines in there yet?
I think I did make them detail lines.
These guys right here. So it was like disappearing down here. That's the issue that you're having. Like disappears under the counters over there. So if we use a model line, okay, you get a placement plane, and typically it's the plane of the view that you're in. So this view right here is based on, oh, you got to be kidding me, top of slab, associated level, top of slab. Okay, so if I create a model line, okay, you'll see the placement plane is top of slab. So if I create, I'm going to do a red just so that we can differentiate between what you've done. So if I place this line, we have that problem. Okay, the line goes all the way through, but you know. So what you want to do is you want to make it so that it's above the counter, but still visible in this view. In my opinion, that model line belongs where that line is in actual space. Okay. Does that make sense?
Yeah.
So if I come to here, we can see that this line is an actual 3D object, okay? And this is kind of where I stand on why I use detail lines instead of model lines. So in actuality, this line should be up here where that line actually would be, right? Where the ceiling hits, okay? Somewhere up in there. Which means that in this view, it's not visible. Okay, does that make sense?
Yeah.
So if we bring it, and by the way, all I did was from this view, I moved it up using disc join. I wouldn't recommend doing that because you want it to be associated to something. But what you can do is you can hit pick new work plane or edit work plane. Okay. They both kind of do the same thing for the case of monolines. So what I can do is I can pick a plane. I'm just going to pick the top of the counter there. And so we can see that the line is visible all the way through, right? But if we go to our 3D, we can now see that that line is floating about waist height, which really there's nothing there. So this is, when you see something like this, it's what we call 2.5D drafting. It's not 2D and it's not 3D.
Okay.
It's mimicking 3D space using lines, okay, and they might not be in the right spot, but it gives the perception of what we're looking at. So the problem that you have with this is now if you go in and well, if we make a VR walkthrough, this line's going to be in the middle of the workspace.
Yeah. Okay.
Not as big of a deal, but if we start doing elevations of these spaces, you're going to see that line too, and you're going to have to hide that line every time you're in one of those views. Okay. If I do a detail call out, like a floor plan call out of the kitchen, okay, you're going to have this line running through it. So it's not that it's the end of the world when I have no idea what that is. So it's not that it's the end of the world if you're using model lines to show those for ease of use, but it does make it more difficult in other views, especially in commercial. I see that a lot, and you get people, the battle goes back and forth. Oh, somebody's created these lines that are showing up in all my elevations, and they delete them because they don't want them there. They think it's a mistake. And then the person who drew them as model lines on a floor plan comes to me and is like, somebody deleted all my lines. Like, I've done all this before and somebody deleted them. And so they redo them, and then they show up in the elevations, and then they get deleted. You know, so it's this back and forth battle. When really, either detail lines, drafting lines, or just using that method of the LineWorks tool, which I understand going through and doing the underlay and then doing the LineWorks tool every time something changes is a little bit cumbersome, but it also gives you more accuracy, and it also prevents that issue of kind of fighting over who gets priority on model lines showing up in different places. Okay. So so did that answer your question on how to place model lines in different places? So let me show you another way that you can do this. And it uses a few, you have to make some temporary views, or you can use some views that already exist. So I could use some of these sections. So if I wanted to place some model lines at a certain height, I can make a reference plane, all right? And we're just going to call this. How did I do the reference plane? I used RP, which is a common one, but it's under architecture reference plane. Okay. And essentially, do you know what a reference plane is?
It's kind of like an invisible work plane, right?
It is a work plane. I mean, that's exactly what it is. It doesn't print. It allows you to host objects to it. It's essentially creating a level without having a level bubble. So it's not quite as strong of a datum. It's called a datum in Revit. That's the technical term for it. You have levels, grids, reference planes. Those are the three main datums, datum types in Revit. So if I create this reference plane, all right, it's essentially a plane on which I can work. It's a work plane, literally. So if I call this floating monoline plane, okay, and I come into a 3D view here, okay, and this applies to any view type, but I'm going to work in 3D just to kind of give you an idea. If I create, do model lines, all right, and I can come down here and I now have that reference plane as a placement plane that I can work on, right? And I can show, oh, I can't. It might be so small that it's not showing up. But if I draw on this, all right, it's at that height. Okay. Now if I close a couple things here.
How do you get to multiple screens like that?
I'll show you. Now, the cool thing about reference plates is if I move this, those lines are going to move with it because they're hosted to it. Okay. Same thing with, I don't know, I might be able to get away with doing this. If I rotate this, yeah, there we go. So you can see that those lines literally host to that line. Okay. And this is a cool thing to use when you're doing, well, you saw in Frampton when I had those beams angled like that. I think I actually hosted it to the bottom of the ceiling, but you can use a reference plane to do the same thing. So you create the reference plane and then you host the what is it called? The beam system to that reference plane. And then you can kind of move it around. And little pro tip here, if you're working in a family, have you tried working in families?
A little bit. I haven't created a family before.
At some point, you'll want to get into families and kind of start to play with them, because there's a lot of tools in family making that help you understand how Revit works a little bit better. I used to teach a series on creating families in Revit, and I called it the keys to Revit, because it's literally when you start working in families, parameters start making a lot more sense, working planes start making a lot more sense, and kind of the little tricks on how to manipulate Revit start kind of start having a lot of those aha moments. But one of the things that work planes allow you to do, like I just showed you, actually, we have a family here that see if I can do this relatively easy. Probably not, but one of the things that you can do is, let's say that in families you have something called a reference line instead of a reference plane. And reference lines are pretty cool because they give you lots of work planes. So you see when I hover over that, you have it's kind of hard to show you without moving over, but you actually have the work plane on the end, so 1, 2, and then you have the work plane that's vertical and the work plane that's horizontal. So you have 4 work planes that you can actually work from this one line. And what's cool about that is if I come here and I change the work plane of this, I don't think it's going to let me. I don't know if it's going to let me do it or not. Yeah, it's not going to let me. So what you can do is you can create a door panel. A lot of people use this as a little trick to do this. Right? And then what you can do is you can set this reference plane to a parameter that you can change the swing angle, and now all of a sudden you have a door panel that you can swing in 3D, so you can actually make it look like it's open and closed and things like that. And the same thing applies with this same reference plane. I can actually use these end panels as well. Let's do another extrude. All right, and wherever that reference line goes, those extrusions go in space. So it's pretty cool. It's a pretty cool thing that you can do in Revit using reference lines and work planes. And so if you think of work planes are kind of like the muscles, right? They're actually the bones, and then the parameters between the work planes are like the muscles that you can move and stretch things around and things like that. Okay. So that was probably more in depth than you really wanted to get into, but hopefully it gives you a better idea of kind of how this works and why it works the way it does, and hopefully it'll help you move those model lines wherever you want them. Yeah. So now you can also use actual geometry as a work plane. So if you want to draw shapes on top of geometry, you can do that. Okay. And just so you know, I'm using a keyboard shortcut to set the work plane, but it's this tool right here that I'm doing. Okay. So you just come in and you can set the work plane. So now it decides to show the work plane. You can go in and draw those lines on top of those. Turn show off. And I'm just drawing lines, but you can also do that to create in-place families, like these gable boxes down here. You can use set work plane to set the work plane for creating those extrusions and things like that as well. All right, so that answers that. What else?
I actually saved it. I redid the garage.
Oh, you pushed it out?
Yeah, and I had added a roof to it.
Okay. I just opened whatever the latest one was. Gotcha. Anything else? All right. Well, I'm going to go over real quick site plans and plat lines. This view should be in the one that you're working on, but I wanted to kind of show you how I got here and what we're trying to do with these site plans, so that you can do those when they're sent to us. And the hope is that you can do them in less than an hour. We can make a little bit of money doing them. If we can pump them out pretty quickly and we have a high volume, then it could be, fairly profitable for us to do these. So essentially what we are working on doing is taking these floor plans that we have, and putting them on these sites that Christopher has picked to build on. And this is a plat for an entire neighborhood. And all of these lines are drawn using coordinate system called meets and bounds. Are you familiar with those coordinates systems, like this number right here?
A little bit.
Okay.
Yeah.
So
it's usually like the satellite, right?
Like what?
The satellite. Well,
it's not GPS, but it's basically a coordinate system that tells what angle the line is and things like that. The nice thing is that Revit has a direct translation system, but it's good to understand what the line is, so if something doesn't work out when you're drawing it, you know how to fix it. Because unfortunately, these aren't drawn in a manner that makes sense for us to draw them. They're drawn in a manner for drawing the entire neighborhood. And I'll show you what I mean by that in a second. So essentially what we're trying to do is we're trying to combine our floor plan and these plats to create this right here. And this is required in most cities to get a permit for construction. So the information that you have here is your property lines, which is this box around here with the dimensions on it, You have the name of the street out here, the driveway showing. Christopher also wants to show like if there's a sidewalk and the patios. So we're going to start showing that as well. And then you have the footprint of the building. And he does, it looks like he wants to put the, well, I don't think we're dimensioning this because we have a slab plan. So I'll show you one that we did. Okay. And I'll show you where to get this information too. Like the title, this is a title block. Okay. So you can see we have, this is a corner lot. We have the streets, we have the patio, the driveway, front porch, and we have the property lines. Okay. All the way around. We have a north arrow, which is important for us. And then we also have the building setback lines. Okay. And the building setback lines are important because that's what we have to fit the building inside of. We have to fit all the concrete inside of these lines. Sometimes they can get pretty tight. We also show the dimensions from the corners to a site, to a property line, because, well, how do you think they know where to put the building on the site? Yeah. All right, so like here they know that from this property line, and they'll have a string that's like right there, and they'll know 90 degrees from that string, 6 foot 6 inches over is this edge of the building. And that gives them a pretty good idea. They can start there, and then they can go to the slab plan and lay out where this is going to go. And the reason we do all these different edges is so that they can actually stake all the corners of the slab, so that they can make sure that it fits within the site. Okay, so this is essentially giving the city the information to know we're within the building setback lines. We're not in any easements. They can look at the lot area here, and I don't know. We should probably start putting, excuse me, maybe not. I was thinking that maybe we put the square footage of the slab in there, but maybe we don't do that. So the biggest part of this is getting these property lines in. Okay. And how do we convert this into this? Okay. So the first thing that we have to do, we have to get these lines in. Okay. And the way that we do that is we use massing in sight property line.
I have a
yeah, go ahead.
When we start this, are we going to make duplicate a floor plan and make it site?
Yeah, so I duplicated this, and I probably should have called it site plan.
Okay.
But I just duplicated. You don't have to duplicate with detailing because we don't need any information off of it. And you could actually probably start by duplicating the slab plan. In fact, we'll do that. Just duplicate slab plan. Right? And that gives us the, I'll go ahead and do, oh man, Dayquil did not help me at all. So I'll start with this. I don't know why it gave me those detail lines. I didn't do duplicate with detailing, did I? Delete this. Rename. Oh, do I want to delete that? I don't think I wanted to delete that because it's got stuff that I need. Wait. This is what we're on now, right? Are these monolines? Those are monolines, aren't they? Yep. Okay. So I'll go into graphics on this in a little bit, but right now we just want to get these lines in. So the first thing that we need to keep in mind is that these projects are oriented to project north, okay, so that the front door is facing the bottom of the sheet. We don't take into account how they're actually rotated on the site. So we know that this driveway facing down is not going to work on this site. So we need to keep that in mind, but for now, we're just going to draw this exactly the way it is in here. Okay, so I'm going to show you real quick how to read this, and we'll talk about how to get these numbers in here. So these numbers right here, right? So you've got two sets of numbers. You've got a distance, which in this case is 126.58 feet. All right, and then you have another set of numbers which tells you kind of how the line is oriented. The first number is whether or not you're starting north or south or east or west. It's usually north or south. So we'll make a little compass here. Here's north, here's south, east, west. All right, so what we're doing here is we're making a line that's 126.58 feet, right? And what we're saying is that it is rotated 89 degrees, 4 minutes, 29 seconds east of north. Now, the 4 minutes and 29 seconds is kind of hard to explain, but it has to do with it's like the decimals of the rotation in degrees, but it's more on an Earth latitude longitude scale. So instead of 89 point something, they use the actual coordinates, the Earth coordinates, to indicate what that rotation is. Okay. Now, the nice thing about Revit is that it will actually translate that to points for us. So if we rotate this 89, and then you just use space, 04 minutes, 29 seconds, it'll actually rotate it that amount. And I rotated it this way because it's east of north. Okay. Okay? East of north. Yep. So this one here is west of north. Okay, so this line would go right here, right? And that's that line right there that we just took care of. All right, so now we're going to do, so we have two sets of numbers here. We have 214.53 feet, and that's this whole line here. And then we have another number here, 113.47, and that's just this segment of this site. Okay, does that make sense?
So the 214 is just half of, it stops right here.
214 is this whole line here. Okay. Okay, so if we add 106 and 113, if we add these two numbers, it should be.
Okay, gotcha.
It should be this number. Sometimes it's not, which is a little scary. But it should basically, so I'll show you another example here. This one is 1,211.96 feet. Okay, and that's this whole distance right here. Okay, and then it breaks down from here to here is 331.93, 101.15 for each of those individual spaces. Okay, does that make sense?
Yes.
Okay, so we'll go 113.47. Okay, and now this is west of north. So we started north and we're going to rotate west. So I'm going to start from here and I'm going to rotate 0, 55, 31. I don't have to put the feet in inches or the, okay, it knows what I'm doing with that. Right? And there is that second line right there. Okay, does that make sense how that works?
Yeah, I'm getting it. Okay. So the north, you would stop, literally go north, and then south, you would go, I guess you would.
So if you are, let me undo that rotation. If it's north and then a number and then west, what it means is that this line starts here, okay? and you're rotating it to the west, starting at the center of the compass.
Oh, okay.
Okay. If it says south and then west, then this line is down here, and you're going to rotate it west.
Okay.
The line is on the south of the compass, and you're going to rotate it west. So that would be the opposite rotation there. Okay. I don't think I can. So let me get this back to where it was. So we could spend all this time constructing these, but the nice thing about Revit is that it'll actually let us draw this as numbers in here, okay? So I'm going to show you how that works. All right, so we're going to do property line, and I'm going to do create by entering the distances and bearings, okay, which is what these are, distances and bearings. So we have 1, 2, 3, 4, 5 lines, right? So I'm going to do 1, 2, 3, 4, 5. And the key here is to just pick a spot and start there and then go around in a consistent direction. Don't just add lines kind of willy-nilly. So I'm going to start right here, and I'm going to go to the left because I'm left-handed, and going to the left is awesome. So I'm going to just put in 126.58. We start north, and then with this you can do spaces to, you don't have to put the symbols in. All right, and it does it for you. And then east, so we're good with that. It's a line, right? And we'll come to the other option there in a second. Number 2 is 113.47. It's north, 0, 55, 31, and it is west. Okay, I just put west in, right? So north, south, east, west. I guess these are always north, south. I don't think it can be west. I think I've actually seen it with those swapped, but it was weird, and I wouldn't recommend doing it that way. All right, so 118 north, 66, 1555 east. Does that all make sense up to now? All right, so the next two are a little bit different, and you can see that there's these things here that says C24, C23, L15, C22. All right, and what those are is that this was so crowded that they couldn't put the information there on the drawing. So usually somewhere on the sheet you'll have a curve table and a line table. Okay, so what we do is we go get these numbers, C24 and C23, right? And we come look and see what that information is. Now, I ran into a problem with this one because C24 doesn't start right here.
Yeah.
So I'll come to how I solved that in a little bit, but right now I'm just going to put the information for C24 and C23 in, just to show you how the process works. Okay. So let's go here, C24. So there's a couple things that you're looking at. You have arc length and you have chord length. Okay. Chord length is usually what you're going to be looking at. All right. And then you have radius. And chord bearing, and that's usually what you're dealing with in Revit. Okay, you don't usually have to worry about delta angle or arc length. So the chord length for C, was it 24 was first? Was 99 feet, 82, 99.82 feet, and it was south 460917 east. It's an arc, and then I need the radius, which was 50 feet. R and L indicates whether or not it arcs to the left or arcs to the right, and you'll see how that affects it here in a second. The next one is also an arc. C23, 20.41. You want to read that off to me?
3 space 10 east.
All right, and what's the radius on that?
Hold on. Radius is 25.
All right. Now I'm going to hit OK on this, but I want to warn you first. It's not going to look right. Okay? And it's not going to look right on purpose because I'm going to go through kind of the things that we have to fix. Okay. Obviously, that's not correct. What? Did it really just do that? It really just did that. I get to do that all again. I'm just going to do the lines for now.
Okay.
429. Whoop. 126.58. 3904.29. This one is 118.15 north, 66, 1555 east. All right. Oh, it helps if you turn on property lines. That actually did work. Property lines are under site. Property lines right there. So we actually have both of them. It actually shows all the ones that I've already done. I'm going to hide all of this for now. Oh, yeah. All right, so this is the one that we just did. You can click on it and hit Edit Table. And there's the table right there. So why do you think it's doing this? What are your thoughts?
Is it because the radius was kind of off? Because it connected.
So let's
24.
Let's look at where we started. We started right here and it went this way, but we started here and we were trying to go this way. So how do we make this the opposite? What do you think?
Change the east from west.
All right, so east to west, and now it's sloping up. See? I know it doesn't look like it, but this is only 89 degrees, so it's actually supposed to be sloping up from here. So this line right here, if we take this and we put it right here, it should match this line. What else?
Let's see. It looks like were we supposed to change the other line to east since we swapped it?
Well, we swapped this, right? You mean this?
I'm talking about the second line.
This one?
Yeah. Well, never mind. That will just be period.
We need to change this also. Yeah, change that to south. So now you can see that line is exactly the same. So basically,
okay.
Northeast with this number is the exact same as southwest for that number. Okay. If you just swap that, because if you think about, basically, if you take this line, this straight south, and you rotate it the same amount to the west as you rotated this line to the north, they're the same line, just on opposite sides of the compass. Here, I'll show you. And that's why I made this line right here. So this one's north, and we're going to rotate it. We'll just say 4500 to the east. Okay, so this is, wow, really small text. This is north 4500 east. Is what this one is. Okay. Now I want to make another line to the south. That was the other thing I was supposed to show you, wasn't it? Okay, and I'm going to rotate this one 4500 to the west. Okay, so this is south 45, 0, 0 west. Right? So if I take these two lines and I put them, yikes, right on top of each other, it's the exact same line. Okay. And since all this is telling us is how it's rotated in relation to perpendicular, then it doesn't matter. It's not. It doesn't technically move it way out here just because it's southwest. Okay. So when we're trying to get the proper lines in, we can swap them like that to get it to form the right line. So what I'm going to do is, because I know this should go this way and then down, I'm also going to swap this to southeast. Right, so now we're starting to look a little bit better. Right, this line already looks correct, so I'm going to leave it where it is. Now this curve is a different matter. Okay, I can come in here and I can change this to left instead of right, but I have a feeling that this just isn't going to work. And the reason is because we don't know where this, well, there's no distance given where that's supposed to start, right? So before I show you kind of how I've solved this part, do you understand, does inputting this stuff make sense? You understand how that works? Okay. Good, because there's a test later on. I'm just kidding. So I'm going to keep this. I'm going to get rid of those curves. Oh, wait, I've got it right there. Never mind. Okay. So this right here is essentially what we just created. Okay. Looks like I started here and went down though. Did it a little bit differently. So you can see I did southwest for this one to go down, and then northwest to go up, and then northeast to go over. So I only had to change that one because I started here instead of the other one. All right. So then what I had to do is I had to come over here to this point of beginning, and I had to put the lines in all the way around this area to figure out where these curves started. And the only indication that I had of where these curves started was this little segment right here. So this right here tells me that it's 16.74 feet from this line to the end of L15. All right, so what I did is I went all the way around and I placed this line right here. And once I got this line, I knew that I had a starting point for L15, which is this segment right here. And then I was able to place that.
Wait, so hold on.
Okay.
So the 16.74 is pointing exactly where that's going to be.
Yes, the L15, which remember.
So L15 is 16.74.
No, L15. So L15 altogether is this right here. Okay, so it's 91.62 feet. But just like these numbers are telling us the length of this segment of the line, okay, this 16.74 is telling us that from here to here is 16.74. And we use the bearings from L15 to figure out what the rotation of that line is. So this segment right here is L15. Okay. So this sketch that I did is L15, C23, and C24 right here. Right? It's this segment right here. And all I did is I put this at the end right here. And then I moved it up perpendicular to, or parallel with that line. I moved it up 16.74 feet. And I knew that that's where it was. Okay? And that's the only way that I could figure out how to do it. And I'm glad that I did, because you can see there's about an 8-foot gap. So their surveying was not very accurate. And it's kind of good that we did that because the way it was drawn originally is this right here is incorrect. And you can see if you look at I know it's really pixelated, so it's kind of hard to see, but you can tell that this curve, like where would you say the midpoint of this curve is? And just tell me when to stop.
Right there.
Okay, so you can see that the midpoint of this curve is right here, and it's well beyond our property line right here. Mm-hmm. But if you look at this, where's the midpoint of this curve? This is like right there. So they didn't draw this accurately, and I think they did that because they were trying to close this gap. Mm-hmm. So, but I pointed that out to Christopher, and I was like, this is the way it's surveyed, and then this is the way that it's drawn, which makes the property line much different. So you see, if I close that off, this looks more like what they drew in that other one right here, yeah. And it's way different. So sometimes this happens in surveying. All right. So everything making sense up to now? I know it's a lot,
yeah,
but I want to make
everything is making sense.
Okay.
I'm trying to the last few steps when you say you had to go from the beginning point.
Yep.
So
hopefully you don't have to do that very often. This is not a very good survey. Usually there's going to be something that gives you some kind of indication of how you can, fit those curves in the right spot. Mm-hmm. For me, the only place that did that was here, and there's nothing. See, there's a gap here, and there's a gap here. So I had to use this line and this line to create a square that I could use as a reference.
Okay.
So I don't expect you to have to do that all the time, but you will probably have to look at a site next to it to figure out, okay, this line starts 16.49 feet and it's 45.17 feet here. So I have to place this line from L13 at that point.
Kind of difficult to read, especially like that 6.49. Like, what is?
Yeah, I guess that could be 16.49. Oh wait, I think no. See, that one is hard to read. I don't know. Okay. That's a tough one. So in that case, you would go look at L13. It's 61 feet. So 45 plus 16 is 61. So that's probably a 16, not 6.
Okay.
So yeah, you're right. It is difficult to read. Contractors don't really know how to give the best quality scans, so it's kind of tough to do that. So, but do you get kind of the basic idea of how to get from this to this? Mm-hmm. Okay.
I worked on that a little bit when I was in school.
Yeah.
But
well, hopefully this is more of a refresher, and you can kind of see how to apply that into how to get it in Revit.
Yeah.
Okay. The next step is a little bit tricky, because the next thing we have to do is we have to get the site oriented to the project.
Okay.
Okay. So you can see here that this is Project North. All right. The easiest way to do this, all right, to get this to be rotated like this, is to convert this convert it from the using the table to just sketching it. And the best way to do that is to create property lines. So property line, and then we're going to do it by sketching, and then we're just going to pick the lines.
Man, this seems like somebody's walking downstairs.
It is. It's Joanna. She's coming upstairs.
Oh, okay.
Hi. What's the thermostat set at right there? Okay, can you put it up to 73 for me? Thank you. All right, so I just sketched that. Okay. And now I have this shape that I can use. Okay, does that make sense? Mm-hmm. So that's kind of the easy part. What I need to do now is I need to figure out how to orient that to the house. Kind of the cheaty way to do it is to basically, I'm just going to take this line and I'll probably make it so that these are parallel. Okay. Now it might be that there's another line that's better. I'm just checking to see that it's parallel. Sometimes it's not actually parallel. This is just what makes sense to me, to have the garage parallel to this side. It might have worked out better to do it this way, but that just doesn't quite feel right. You know what I mean? So this just kind of felt like the right way to do it. Usually Christopher will give us the yard setbacks. So in this case, it was 25 foot 6 inches on the front yard, 25 foot 6 inches on the backyard, and 5 foot on the side yards. Okay. This is a straightforward lot because it's not on a corner. You have a defined front and a defined back, and you have sides. On a corner lot, sometimes it'll already be defined which is the front. So in this case, the front is this one. So you see the 25 foot building line. BL is building line. BL building line. UE is utility or easement, or utility easement. And then sometimes there's another one. But these are basically off limits for building. Okay, so you have, there's, you know, gas lines, water lines, things like that that are buried there, and they don't want you busting them, obviously, because they're expensive to replace. So we need a 5 foot setback on the sides. Okay, so what I essentially do here is he wants 5 foot 6, so I just move this 5 foot 6 right there. I dimension, and then there's a couple ways to do the next part. And what I used for this one was I just used property lines. So I'm going to create a new one. So create similar by sketching, and I'm going to do the building setback lines, right? So I'm just going to do 25 foot 6 inches. I'm just going to pick right there. Right there. I don't need it right here, this line, because this goes all the way across. Right? And then I'm going to bring them right here, and right here. Okay. And then I'm going to do that again by sketching 5 foot 6 here, here. And I do those as crossings so that you can get, you could make it to where it was just a box around there, but I like it to go all the way across, especially if the sites are connected on each side, so that they know that it's a continuous easement. It reads a little bit better. And then I did a little bit of graphic stuff to make the property line bold, and then also I changed these lines using override graphics by just changing the pattern. What did I make it? I think I just made it dashed. A long dash or something like that. So it looks a little bit different. And then I think I used override graphics to make the property line a little bit heavier. You know what? This needs to be like one. There we go. So I do that so that it reads a little bit differently. Okay. This project that I used here, I have some tags that I used to label the 25-foot building line, 10-foot UE. You can use just text. I also use tags for the property lines, but I think instead of putting the bearings on there, we're just going to do the distances.
Okay.
And the reason is that because once you see here, tags. Excuse me. Once you start rotating these, oh man, what? Different tag. Insert, load family. Annotations, civil, property line tag. Bring both of these in. So you can see that once we've rotated it, you can see that it doesn't look the same as it was before. Okay, so what we'll probably do is probably just make it a tag that's just the distance for these. That other tag that I actually loaded was the one that I was actually looking for. Property tag, property lines, site, property line. Did I not? Property line setback. Okay, so this is the one you can do 25-foot building line. And the reason that I did that as a tag is because it's really hard to get your text to rotate exactly the same thing. Yeah. So when you have it as a tag, it rotates exactly at the right spot, and like you can put it anywhere in the curve and you see how it follows the curve. Mm-hmm. So you can do that right there. And then you'd label your streets. The driveway, I just use a filled region. Concrete. Filled region, and you would want to be a little bit more detailed about it than this, but that's essentially what that is. Except you want to make sure that you use the right line types and put it behind everything else. I don't know why this is concrete. Be transparent, I guess. Transparent. There we go. Right, so you go and do that. We don't need any of the walls showing, so we can turn those off. I don't know what these are. I don't know what that is, but we don't need it showing here. So that's essentially it right there, right? And then all this stuff would go away. So, what do you think?
I think it's.
I mean,
I can do it.
Think you can do that?
Mm-hmm. Yeah.
And I know I just did it, but you get to do it again for for this project. Okay. So I'm gonna let you give this one a shot, because we can kind of build some of that training time into the project a little bit. We'll kind of split the training time between the project and straight training under your timesheet. So we can do that. You'll also want to put the patio back here. Be sure that that shows up. And the title block you can pull from. See if I can remember where that was. This was a was it a Rizzo? Christopher plot plan. Highlands Ridge plot fit. Wood plan. So under wood, base plan. I think I just did. Maybe it was a short and narrow. I hope I saved it in there. A GR? No, it's a GL, isn't it? Open the wrong one. Well, crap. One thing that I didn't mention while this is going is the north arrow. The north arrow is already loaded into the project. You just drop it in as a symbol. But you need to keep track of how much you rotated the property lines, so that the north arrow rotates with it also. I'll show you what I mean by that here in a second, because you want the north arrow to actually be pointing north, obviously. And it's actually the opposite. So if you rotate the site this way to get it to fit around the house, then the north arrow rotates the opposite direction.
Okay.
I really hope I saved all this in this project. I don't think this is a short and narrow though. Site plan. See if maybe it's just the GL. Any questions while waiting for this to load? Probably more after you give it a shot.
I'm looking at that site plan right there. I'm looking at
This one?
Yeah.
Yeah. This one was a little bit trickier. Most of the fronts will have a curve to them, but this is a corner lot, so it's a little bit different. Oh, I did save it. So wood GL. So this title block, you can open it and load it in. So edit family, load in the project, and then you just make a new sheet with that title block and drop the site plan that you made in there.
Wood GL.
Yeah. Cancel. Nope. Cancel. So the north arrow. I'm going to come back to before I rotated here. There we go. You put the north arrow on in the view, so it's just symbol and then north arrow. Drop it on here. All right. So this is north compared to this right here. Okay. So what I would need to do is I would need to figure out, let's see here, move this to here, rotate. What that number is in order to get it to be like this. So if I want this line to be basically straight up and down, which I think it is. This is just 0. Yeah, that's 90 degrees. So this, I mean, this takes a little bit of temporary magic to figure out. You have to make some lines to. So this is 90.93 degrees, and you don't have to be like super hyper accurate with it. All right. So in order for this north arrow to be correct, I have to rotate this 90.93 the opposite direction. All right, and you can kind of just look at this and verify whether that's correct, right? Because we know that this is north on the plat. Okay, so this is going to be pointing up towards that side of the property. Right. So when you create that sheet, you want to be sure that this shows, and you might have to move it around somewhere. So.
Okay.
All right. All right.
So do you want me to work on that first?
No, this can be the last thing that you do.
Okay.
I'd finish that up and then do the site plan. But the site plan will be printed separate as an 8.5 by 11.
8.5 by 11.
Yep.
Okay.
All right. And this one that I already did, you can find under Patriot Home Building plot plans. And it has the Yorktown plot, which is what this is going to be, and it has the has the Yorktown plat. It has the reference that I did, and this lot is block 41, lot 26, and it's actually the one that's in there, 2641 Yorktown. It's the same one, but we're putting a different house on it. Look at that to see. And then the lot 24, block 15, Highlands Ridge is the one that I did for him. I think ours looks better.
It does.
All right.
Cool.
Now you can go take a brain break and
All right, thank you.
kind of compress all that. And